Hello and welcome to the first in a series of 3 videos where we'll be looking at the Joule Temperature Plotter project. This project was designed as a cheap and simple means of logging accurate temperature measurements with a graphical display for use by school science classes or home learning. The project is free to use, but please let me know how you use it. I provide 2 clients which read and record the data. One's written in Java and is intended to run on a Windows or Linux PC. The other is an Android phone app. Both clients connect to the same custom hardware via Bluetooth Classic. The custom hardware is very simple and is based around 2 DS1820 temperature probes, an ESP32 with USB cable and a 4.7K resistor. The ESP32 provides all the control, connectivity and power regulation required. The USB cable is required for the 5V supply and also provides a direct serial data connection. If the probe is to be remote from the client, that is not powered from a USB port for PC, then a 5V battery pack will need to provide the power via a USB cable. The software for the ESP32 module can be found on my GitHub site and is given in the cards at the end of the video. You will need an Arduino IDE to upload the code. Before the temperature plotter can be used for the first time, the temperature probe must be powered up and the PC or Android device paired to the Bluetooth server of the temperature probe. You will see the Bluetooth server listed as temperature probe when it boots. The PC application provides the most complete set of functionalities of the 2 clients. It depends on JFreeChart from JFree to display the temperature data and JSerial.com from Phasecast to provide the serial connection over the USB cable or via Bluetooth. The code is Java and is supplied as an Eclipse Maven project. The 2 DS1820 probes each provide a trace on the graph, distinguished by blue and red. Before starting, the appropriate COM port needs to be selected from the module serial port drop-down list. Both Bluetooth and USB serial connections show in the same fashion. If the manual option is chosen, then once the start button is clicked, the sample will continue until the stop button is clicked. With the automatic mode, you can select up to 1,000 samples, which will continue at the rate selected, once per second maximum, until complete. The Android client is not required to use the project and provides only a small subset of those available to the PC application. It was really just an opportunity for me to practice with the MIT App Inventor, but it might prove useful as a basis for future development. Okay, so let's start some demos. So at the moment you can see the probe sitting on this blue mat. It's connected to a USB port now, so a port has been allocated. The 2 temperature probes are now sitting in roughly the same sort of temperature, so it's around about 30 degrees centigrade. There's a water bath currently empty that's sitting there. What we're going to do is we're going to run the Java application, see the trace being generated, and we're going to put one of the probes into the water and basically see how the trace sort of is affected by that. So let's put that into practice. So I'll now fill up the water bath. This is tap water, slightly cool, and there we are. So this is the temperature plotter. At the moment it's not displaying anything. The first thing we need to do is to set the port, and this is in the module serial port. There's only one in the list, it's COM6. At the moment we're set to manual, which means if we switch this on now, it will just continue sampling forever. You need to put a sample rate in here, which we'll do that now. Put 60 per minute, and then we'll change the title to the demo. And oh, that's a bit odd. That's better. We'll change that. Actually, the title will change, and that title will also be saved with the file when we do that later with the trace. So now we can see at the moment that the 2 probes at the same temperature. At least we will when we start this. Let me do this. We'll set that to 60. So in other words, when I click start, I'll get 60 samples in over a minute. So let's begin that. And now it's started. I'll now put the red trace into the water bath, and we can see immediately that it starts to go down. So a real-time monitoring of the temperature of that probe now. So what I'll do is that once this is completed, I'll save it, and then we'll have a look at another graph that I did earlier, just to show you the versatility of the system. And also I'll show you a few things, features of the trace area as well, that might be useful. So it's coming up to completion now. And there we have it. Yeah, finished. So one feature that might be quite useful as well, especially if you're just testing the connection to see if it's working, especially when you're working with Bluetooth, is to click on single sample. And as you can see there, it just samples the red probe and the blue probe and gives you an instant value, which just gives you reassurance that it's monitoring and is working successfully on the connection. So let's save this graph. I'm going to save it as my demo. And that's been saved. And now I'm going to show you this other trace that I did earlier. So I'm going to load the graph and I'll put in the filter. And go to the back here and freeze a demo or freeze a test. We're going to open that. And there we go. I imagine that some of this is probably hidden, but you can see the whole path there. What's actually going on here was the actual probe was placed into an upright freezer. The black area, the black box, was put in the middle shelf. The blue one was put onto the top shelf, and the red probe was put onto the lower shelf. And then the door was closed. And then we started the monitoring. So you can imagine what happened here. This was a Bluetooth connection. Obviously, we can't have cables sticking out of a sealed container. So this is actually a trace created using the Bluetooth connection, which is obviously a major feature of this. And as you can see, they both started at roughly the sort of same temperature, and they both declined and eventually merged at 720 seconds. So obviously the blue shelf was cooling slower than the red shelf, being right at the bottom. I can show you some other features of the trace area. If you right click, you can see properties, copy, and save as, and print. If you do copy, then literally you're just copying the graph area and you can paste it into a document or whatever you particularly want. Save as, you can save that as a PNG file, or print if you want to. Obviously you print it. It's a fairly high quality print, and you can obviously do measurements from that, so it's pretty good. Zoom in, zoom out, I'm going to leave that, but you can experiment with that. And auto range also allows you to set the ranges in the domain and the range axis. In a similar sort of way, I've got this auto range feature included as well. What that basically does is just display the area that's currently being actually being used. If you've only got sort of 30 to 0 degrees, but only sort of 10 degrees of it's actually being used, you use the auto range and that stretches it to fit the entire graph and recalibrates it. Also, you can do the blue trace and red trace is currently ticked because they're both being displayed. But if there's one particular one you want to concentrate on, you just click on this and you just remove it from the display and just bring it back again. So that sort of thing. Now I'll bring back our original saved graph, load graph, and it was called My Demo, I think. And open. And there we go. So that's the graph that we did together, and it's all displayed. And that is it for the demo. Okay, so now it's time to look at the hardware. We can see it here, and in a few minutes' time we'll be programming it to get it to work with the client. So we have a blank ESP32 here, but it's all connected up as it will be in the diagram that we'll see here. We've connected, the way that these are connected are basically in parallel. The bus, the one wire bus, is connected to the GPIO pin using a a pull-up resistor, which is the traditional way. Well, it is the way in which you power a one-wire bus. So that is it. There's nothing additional to this. And if we take a sort of a closer look at the diagram itself, if I just get onto here and show you, that's a bit clearer, I think, to how it's done. It's literally just these two probes in parallel connected across those three buses, and in this particular case, the yellow line marked bus connects through to the GPIO 13. So now we can start programming, and the first thing we've got to do is obviously connect the bus. So the USB is now connected, and now we'll have a look at the actual coding. So here we can see the Arduino IDE. It's got the code already in it. We'll have a quick look through what's involved in this. This has just been downloaded from my GitHub site. It's got the three libraries it needs. Obviously, you've already this assumes you've already programmed the ESP32 board, or you've downloaded the libraries necessary for that. There's a link on the README page to tell you how to do that if you haven't already done that. But what you'll get is the one-wire Dallas temperature and Bluetooth serial, and you need to include those. And what it effectively does is to create an instance of the serial Bluetooth. Then you're obviously defining which GPIO pin the one-wire bus is connected to, and that's going to be 13 in our case. You then pass that information into the one-wire. Then you create a Dallas temperature instance, which we're calling sensor, and we're passing that one-wire connection in because that's what the Dallas temperature object will be using. We find out how many devices we've got. We obviously going to have two in this particular case. You can extend it, but in this case we're just sticking with two. We have the red and the blue, and we give a device address. So that's a Bluetooth device address set up there. Then it hits the setup function. So obviously with Arduino, this is the first thing that runs when it boots. It sets up the serial, which is the USB serial connection at a particular speed, and it flushes it ready to start. It then does the same thing with the serial Bluetooth connection, and it begins. What we do here is to set a particular string, which is an ID for when we start looking for the Bluetooth connection. So we'll be looking for temperature probe, which we'll have a look in a minute. Then we just print out that it's now ready to start to pair with the Bluetooth. The sensor then is started. We then gets a device count back. So the sensor is now used. The one-wire bus is now communicated to, and to give a total count of the bus of the connections of the devices on that bus. We then have some various printouts. It checks to see whether we've actually got the two devices that we're meant to have on this bus. If not, we get a probe. We get a warning. Otherwise, it just drops through. And we set up the red and the blue connections, and it prints out the address of the red and blue probes. The red one is whatever one it finds first, but it's usually consistent. So if you mark it with the red tape, it should be the same one that when you boot it again. So red and blue is set up in this way. And skipping over that, we'll just go to the loop. Obviously, once it's completed setup, it goes into the loop, and the process is waiting for activity on the serial and also on the Bluetooth connection. So it listens on both, and whenever there's anything on there, then it will immediately run the on receive function, and then it will just repeat over and over again once that function is completed. So what it's actually doing is it's looking for any traffic, and what we do for the client is simply send the @ symbol. You can send anything you like, but the @ symbol is what we particularly send, and that is the trigger for the whole process of reading those temperature probes. So what does onReceive do? Well, it sets up basically an array ready for some characters to be put into it. It reads both the serial USB connection and the serial Bluetooth connection, and immediately after doing that, it basically cycles round until those buffers are empty. So it doesn't really care what's in there. It just flushes them and removes them. But the important thing is it's triggered the event. So then we go on to use the sensors to request the temperatures, and we set up a floating value for the red and for the blue probes. Just set them to zero initially. Then it actually reads those temperatures. So the function read temp C. You pass the address for the red device, you pass the address for the blue device, and the appropriate ones come back and set up those floating values with a value in C. The SNPrintf just takes those two values that we've just pulled back and puts it into a string. So we get two floating point values, the first two separated by an @ sign and the last one with an @ sign at the end. So that's the format that gets sent back to the client. And that happens at this point here. It gets sent back on the serial port, the USB serial port, and for the serial Bluetooth port as well. And that's it. So your client will be listening on one of those two, and will therefore take that output and sort of deal with it appropriately, whatever that happens to be. And mostly it's taking those values and plotting them, and that's the general idea of this. Okay, so let's program it. As you see, we've already got an ESP32 dev module set up up here, and if you click on there, we can see that COM6 which is my connection here, has already been established. So what we need now is to upload this information, to compile and upload. So if I go back to the output, click on upload, then we should see the sketch beginning to compile, and in a few seconds it will be complete. And there we go. It's now uploading the code. And that's done. Okay, so let's get it to read the probes now. If we go back to the serial monitor, I'm going to do a restart or RST. It disconnects for a while. It should come back. There we go. So what I'll do now, if you remember that to actually trigger any activity, and this is basically a means of putting some information onto the USB serial port, I'm just going to type, as it does with the client, I'm just going to put the @ sign in and hit return. And this is the result. So that one line that we can see there is what we get back. So that's the red temperature, 24.37 whatever degrees, and the blue probe, which is 25. So obviously there's a difference there. The probes are slightly different. One's on the mat and one's slightly above the mat. So there's going to be a temperature difference there. So we've tested the serial ports. Let's connect to the Bluetooth. So the first thing I need to do is to pair it up. And I can do that here. Add Bluetooth device. Bring this over here. And hopefully in a few seconds it will display something. I want to add a device, so I'll click on that. There we go. Click on Bluetooth. And there we are. As promised, the temperature probe is now displaying here, and we can connect to it. So if I click on there, connecting, and we are connected. So we've now got a serial connection through the USB port and a Bluetooth connection. So now we have a Bluetooth connection. Let's test it. So first thing I do is to start up the executable jar file that you can download from the website. Double click and it should start up. There we go. I'll maximize it. No, I won't, because I want you to see that port. So I'll minimize this for the moment. Now the important thing is to look at the module serial port list now. If you remember previously COM6 was what was available. So that COM6 is actually the USB serial connection. But now we've got two new COM ports that weren't there before, 5 and 7. You get the Bluetooth connections paired in this way. So you'll get two COM ports, but usually only one of them works for reasons that I haven't gone into, but the one for me is COM7. So you'll probably have to experiment and see which one does. I think if I do COM5, it says module is connected, but I think if you do a single sample, it doesn't do anything. That's right. So that obviously isn't the port that works. So what he'd probably do is just go to COM7, if it will do that. Yep. So there's a bit of a warning about serial timeout, but that was the port that didn't work effectively. So now it says connected again, and I'm going to do a single sample, and there it is. It works. So that is the value that's come back over the COM7, which is the Bluetooth. And also, if you notice down here, we've got something coming back here. So this is listening on COM6. So we're getting both traffic coming back from the serial port, from the USB serial port, and also the Bluetooth as well. And let's just test it a bit further, really. Let's do some proper testing, and I'll do 30 samples. We'll do our 60 for a minute, and then we should see quite a few things coming down, one a second coming down here. And if I start that, it didn't work. Why was that? I'll start it again. Working now. So if I actually put my hand on here onto the blue probe and squeeze it, we should now see some action. That's a bit weird. That's a bit of an error creeping in there. I think it's a bit of a dodgy probe here. But as we can see, we are actually getting our full 30 samples. And they've always been recorded both through Bluetooth and through the serial port. Okay, that's fine. But the issue is that we are still using power from the USB port. What we really want to do, if we're going to be using the Bluetooth, is to use basically a power brick of some kind. We're going to use something like this. And what we're going to do is now turn off the USB supply. So we've now broken the connection. So now what we do is to reconnect it, but connect it to the power brick. And we do it like this. There you go. So now it should be booting up. And I'm going to shut this down and restart it. And then we'll have a look at the COM ports again. We should find that COM port 6 has disappeared, but the two Bluetooth ones remain. So let's prove that. There we go. So 5 and 7 are still there. COM6 has disappeared. So we've gone to COM7. Module is connected. So there we go. We've got an active temperature probe powered from basically the brick, and it's now able to be deployed in a place that's obviously within Bluetooth connection but not physically connected. So let's prove that everything is still working. I'll do my usual 30 samples at a rate of 60 per minute and start. There we are, it's connected now. And I shall put my hand over the blue probe just to prove that we are monitoring it. And there it goes. Yeah, something wrong with the blue probe right now. But that's one of those things. It's working fine with the other. Okay, so we'll wrap up this video by a quick demo of the Android app. If you downloaded the APK file, you can install it. In fact, let me do that now. And if I go to download, there it is. That's the Joule temperature probe APK file. If I click on that, then it says, do you want to install? There may be some security requirements that you need to check before you can do this. I've gone through that, so I can go this far and do install. And it takes a few minutes, but it will then install and the app will then be available for you to use. And we'll take you through some of the basic things that it can do. Okay, so that's now installed, and we can just click on the open button. It goes straight in. So what we can do is to start sampling, and we can do that now. But you've got to select the probe first. We select the probe. This is all, obviously the Bluetooth connection has already been made. We've already paired it in to the app. So if I go down here and go down to the bottom, it's now fairly familiar. We've got the temperature probe as we did with the PC app. So we click on there, and now it's ready to sample. So you click on the sample, and then makes the connection. It's successful, and it starts to do the plotting. It's very much like the PC app at this point. There's no, it's really like the manual version of the PC app. There's no timed thing. It will automatically sample every minute, and will complete when you press the stop sampling button. So let's do that, and that's it. Actually, I probably should have showed you that it does actually change. Let me do start sampling again. I'm going to hold on to the red probe, and there we go. That's a little bit better. So we'll stop the sampling there, and we'll show you some features of the actual plot area. You can actually stretch these as well and pull them out. And if you get close enough, you can actually see that each plot is individually numbered, so you know what the temperature is. And you can just scroll it back or pinch it back. There you are. And you also have the facility to save the plot and to restore the plot. Unfortunately, you can only save one on this particular version. So it's basically an array that gets used each time, and that array gets overwritten when you save it again. But really, this is just a demo feature, and there's scope for improvement, certainly. So I hope you've enjoyed that, and we'll move on. And this is the end of the first video. There's going to be two more. The second one will be about the PC application itself, so we'll take a deep dive into the Java application. And the third one will be the Android application. That's using MIT App Inventor, and we'll just have a quick look at that. So all the code is available on my GitHub, which is sitting here. So please enjoy. And if you have enjoyed, please like and subscribe. Thanks very much.